I just want to go over in this video the whole process of when we started, or I guess between when we started with the factorial problem and ended up at the runtime. So the first thing we did after defining the factorial problem was work out a few examples and figure out this formula for figuring out the factorial, which was that if we wanted to know the factorial of a number, we could take the factorial of 1 less than that number and just multiply that by our original number. And so this we generalized to a piece of code right here, this def f of n, where f of n in its function definition had an f of n minus 1 in it. Our definition for f involved f. So that was a recursive function. So after writing some code over here, we wanted to figure out the runtime of it, and the first step that we did was we figured out the recurrence. We figured out the recurrence relation, which was big T. And big T, much like this f over here, this big T representing the runtime of f was also in terms of itself. Right? We said that the runtime to figure, or the runtime to run, the runtime for f on an input of size n was exactly equal to the runtime for f on an input of size n minus 1 plus some constant amount of work. And so after figuring out the recurrence relation, we used the unrolling method. To solve the recurrence relation, which I guess I'll just denote or abbreviate as RR. And so these 3 steps, going from code first to the recurrence relation, and then to solving the recurrence relation using some sort of strategy, will be something that you'll see over and over again, especially in 250.